Welcome back, everybody. We were finding surface area, doing surface integrals for functions of more than one variable. We've done it with regular x and y. Now we're going to look at doing with parameterized equations. Just recall from the first video we did, we had our integral was the square root of dz dx squared plus dz dy squared plus 1. But that radical, that part right there, stemmed from the normal vector, taking the norm of the normal vector. So, which was q2 cross q1. Well, if we parameterize it with u and v, we've got dr du and dr dv make the normal vector. So, rather than using this as our normal vector that we're having in there, we're just going to replace s with that. Okay. So in the last problem, we looked at finding, we did prove the sphere was radial, the radial vector was normal everywhere. We can look at finding the surface area. We're not going to do the sphere. We're going to do another problem though. So we're going to have our surface is y equals z, and y is going to go from 0 to 4, and we'll revolve that around the x-axis. So I got a picture down here. Y equals z, and then we're rotating it. I said around the x-axis. That should be around the y-axis. Okay. So I make a little triangle. So I got this cone, really. And so from any point along there, I can make a triangle to the point. We're going to call the distance to ZU, and this distance is, or the angle will be V that it makes with the XY plane. And I think I got U listed wrong. The U is the magnitude. Let's see. Yeah, I got U written wrong. Sorry. It is not the distance to Z. It is the hypotenuse of that triangle. Because if this is X, we got cosine of V is going to be X over U, adjacent over hypotenuse. So U is the hypotenuse. So we're going to use X equals U cosine B. You'll note when we got it pointing straight upward like this is a distance Z, and Z is Y. So we're going to say Y equals U. And I'm sorry, Y equals U. And then for any normal Z, not just the straight up, the one where we're directly above the y-axis, oh God, I'm brain farting. Sorry. The Z component is here. We're doing U sine B. So that's up. We got U sine B. We can see that the radius, we're going from any point along Y here to the edge of the cone is just going to be Z, because if we do it straight up, it's hitting right there. So Y will be U, because that's the distance from the Y vector to the surface. Okay. So we got R is U cosine B, U, and then U sine B. God, I mangled that. So let's find our partial derivatives. dr to U is cosine B, 1, and sine B. dr dv is negative U sine B, 0, and U cosine B. We do our cross product. We find our normal vector. We've got U cosine B, and then we've got negative, because the j hat's negative, U times cosine squared V minus a negative is plus U times sine squared V. And then we've got for our k component, U sine B. You'll notice that we could factor out a U and have cosine squared plus sine squared, which will cancel. just giving us a u there. So negative u will be our middle component. So the normal vector is u cosine b, negative u, and u sine b. We take the magnitude of it. We got u squared cosine squared b plus u squared sine squared b. We can factor out a u. Not factor out a u squared, pull it outside. We got the magnitude, the absolute value of u, sorry. Get the absolute value of u outside. Then what we have left on the inside, we'll have a 1 here. We have that plus that. Cosine squared plus sine squared together make a 1. So we got 1 plus 1 is 2. Okay. Let's take a look. We got our normal vector now, or the magnitude of our normal vector. And that's what we're going to take the integral from, because that's what we needed right here. Okay, so let's do that. We got absolute value of u times the square root of 2. So absolute value of u, I'm just making it positive because u is going from 0 to 4, because u was y. Okay. We're doing a full revolution, so r will go from 0 to 2 pi. And we've got 0 to 2 pi, 0 to 4 of u square root of 2 du dd. I said r, that's v. V was the angle. V is effectively the theta along that curve along the y-axis. So we integrate this bad boy. We got 1/2 u squared times square root of 2, so square root of 2 over 2, u squared from 4 to 0 just gives us 8 root 2, and we're going to integrate that from 0 to 2 pi. So we end up with 16 pi square root of 2 units squared. That's it. That's it for 14.4. These are the equations we had. Just to remind you, wrap it up real quick. S equals the double integral across R of the square root of dz dx squared plus dz dy squared plus 1 dA. And we can also do across our region R, the norm of dr du cross dr dv dA. Okay. Peace.